Let us recall the fundamental concept related to probability. The probability that an event A happens, if we can represent it as P of A, then the probability that the event A, it won't happen, that is P of A bar, and that will be equal to 1 minus probability that the event A happens, that is P of A. Now let us consider the situation when one bomb is deployed, that is n is equal to 1. That is when one bomb is dropped. In the question it is given that one bomb has a probability of only 20% of scoring a direct hit. So the probability of success, it is equal to 0.2. 20% can be represented as 0.2. So the probability that this bomb, it misses the target, it will be equal to 1 minus 0.2, and that is equal to 0.8. Now let us consider the situation two bombs are deployed, that is two bombs are dropped, that is n is equal to 2. Now the probability that both these bombs they miss the target, that is probability of failure, that will be equal to 0.8 into 0.8, and that is equal to 0.64. Now the probability that at least one of these two bombs they hit the target, it will be equal to 1 minus 0.64, and that is equal to 0.36, which means there is 36% chance that the target is going to get hit. It may be because of the first bomb hitting the target, the second one missing it, or the second one hitting the target and the first one missing it, or it may be because both these bombs they hit the target. Now let us consider the situation when n is equal to 3, that is 3 bombs are deployed. Then the probability that all 3 they fail to hit the target, it will be 0.8 to the power of 3, and that is equal to 0.512, which means the probability that at least one among these 3 bombs they hit the target, it will be 1 minus 0.512, and that is equal to 0.488, that is 48.8% chance that the target is going to get hit. Now in the question it is asked what should be the minimum number of bombs to be dropped so that the chances of successfully completing the mission, that is the target is getting hit, it is more than 60%. Here it is only 48.8% when 3 bombs are deployed. Now when 4 bombs are dropped, that is when n is equal to 4, the probability that all 4 they fail to hit the target, it will be 0.8 to the power of 4, and that is equal to 0.4096. So the probability that the target is getting hit at least by one among these 4 bombs, that is equal to 0.5904, which we get when we perform 1 minus 0.4096. So there is 59% chance that the target is getting hit when we drop 4 bombs. Still it is not greater than 60%. Now let us consider the scenario when 5 bombs are dropped. The probability that all 5 they miss the target, that will be equal to 0.8 to the power of 5, and that is equal to 0.3277. So the probability that at least one among these 5 they hit the target, that is equal to 1 minus 0.3277, and that is equal to 0.6723, that is 67% chance that the target is getting hit. This is seen happening when n is equal to 5 or more than 5. So the minimum number of bombs to be dropped so that the chances of successfully completing the mission is greater than 60%, that is equal to 5, minimum 5 bombs to be dropped, and that is the final answer for this question.